Hello again. This is part 3 of the investigation of the usage of CDI systems in cars. We haven't got to the CDI systems yet, but today we're going to look at the Kettering system and look into that a little bit. So Charles F. Boss Kettering developed essentially the modern ignition system and the self-starting system for cars and the electrical generation system and battery to go along with it, although the battery is already developed. And he did a whole lot of other stuff. Electric motors and cash registers, the production of tetraethyl lead, which was good for engines at the time and not so good for the environment later, and Freon for use in modern refrigerators and air conditionings, kind of the same thing, was good at the time, not so good later. But anyway, nobody, of course, knew about that at the time. He was a very smart guy, had an electrical engineering degree, and from Ohio State. Basically, him and some partners started Delco. So anyway, this next slide is basically the basic Kettering ignition system. Now, having looked a little bit into some of the stuff he did, it seems like he was really good at adapting existing components into a system efficiently. In other words, to take what was already out there, make changes to it as required, and then come up with a new way of using it. And really, the ignition system is no different. Now, starting on this diagram, starting from the right side, the spark plug, of course, had already been developed and was being used. Points were used in magnetos, so that was nothing new there. Condenser or capacitor, once again, those were being used in magnetos and in the Ford spark coils that we saw the last time. The coil, I mean, there was the beginnings of that kind of thing, again used in magnetos. But the thing on the left is the thing that's different. The automobile storage battery. And that is really what makes the difference in this case. That is what makes his system work better than what had worked before. So before, there were dry batteries, usually those big old number 6s or something similar. And they're fine, except they have a lot less capacity than a lead acid battery, number one, and number two, they have a high internal resistance, or higher, I should say, internal resistance than a lead acid battery. For the system to produce a hotter spark, you need more current in the primary. And the dry batteries just aren't going to do it for you unless you stack up a lot of them. And I think that was the key difference when basically switching over to the lead acid rechargeable battery and the generator and the starter and the lighting system and the Kettering ignition system all happened basically at about the same time. He developed the entire system. Now, some of it was put out in automobiles in pieces parts, not necessarily all at once. But this was his vision, and that's essentially what happened. So with the higher capacity battery, you could now get a much hotter spark when starting the car, without having to rely on either a lot more dry batteries or turning over faster or coming up with a more efficient magneto. And basically it was simple and effective, and it worked. And that is one of the reasons why it lasted so long. It basically was, it's one of the things that goes, if it's not broke, don't fix it. So the next slide is a little bit more in-depth look at it. Basically, as the call-outs say, the battery provides the voltage. Then you have the points, which are opened at a particular time. Now we're talking about a distributor now, a modern distributor with a cam in it. Points are in there, and the capacitor's in there as well. The points open up. Now the capacitor, they talk about it having the action of keeping the points from arcing over and burning, and that's absolutely true. But the capacitor actually has another function, and that is to act as resonance for energy storage with the primary of the coil. And that is not talked about that much, I think largely because it's people probably wouldn't understand it that much, and it really isn't necessary to talk about it that much. People do understand about the arcing of the points. We will talk about this in a little more depth later on. And then you have the coil as the next item. You've got, a few turns of primary and a lot of turns of secondary. And then, of course, you have the high tension going off to the spark plug on the right side. And on the next slide, here it is, fleshed out a little bit more with showing the distributor, and then it basically the rotor and the cap distributes the high tension out to the various spark plugs. Now this one you can actually kind of see kind of a schematic of what's going on inside the coil. You notice that the primary and the secondary are connected at a common point. Now the reason for this is if you look at the way when you open up, when the contact points open up and you induce the voltage in the primary, by connecting it this way, the energy in the primary will add to that in the secondary as well. So it's not just being wasted. So they're doing this for a reason. It's not just to keep there from being a fourth contact on the coil. And the next slide is kind of more of the same. Just you can actually see the cam here, the points, and the condenser inside, and then the spark plugs. Now, next slide is a picture of a typical ignition coil. You can see we're all used to these. They bracket inside either on the engine itself or on the firewall. Usually it's a better idea to put them on the firewall because there's vibration with their engines and enough shaking, and that'll start to have problems with breakdowns in the secondary, especially if it's a cheaper coil. And here's one with the can removed. Now these are normally filled with oil for cooling, and or some of the more modern ones have epoxy. I think they also used the old tar stuff that was put in old coils way back. Sometimes can be used in the real old ones, and that stuff's a mess if you ever have to deal with it. The reason you need cooling is you can see from the primary windings there, you're going to run some current through that primary. One of the things that people say is don't leave just the ignition on without starting the car because you'll burn the points up if they happen to be closed. And that is true to some extent, but what you really do is burn up the coil. You'll have a lot of current going through those primary windings, and it'll heat up pretty fast, especially if you're pumping 4, 5, 6 amps through it or more. And here's a cutaway version of the coil. You can see the primary is actually outside of the secondary, which is, a whole bunch more turns. Usually the turns ratio of primary to secondary is somewhere on the order of 50 to 100. And then, of course, it has an iron core, and that's the reason that's there is to increase the inductance, which we'll show you why that's important shortly. So basically that's the system. I think most people understand how it works. You've got the points which are closed. You've got current flowing in the primary. The points open. When that happens, the magnetic field in the coil, which has been set up by the current flow, collapses, induces a voltage in the primary, and of course there's back EMF because of that, and that basically goes down into the capacitor. Then that induces another voltage in the secondary, which is much higher, and that is routed out to the plug. The plug fires. Now there's some resonances in there. Some energy is swapped back and forth between the capacitor and the primary, what's called a tank circuit. And that will continue to feed energy, the stored magnetic energy basically, into what started out as stored magnetic energy, through the wires and through the spark plug. And so you end up, and we'll show you this on some upcoming drawings, where you have a spark duration of, a millisecond or something like that. So it's not instantaneous spark. Now on the CDI systems, when we talk about that, their spark is actually much quicker. It doesn't have that long burn that the Kettering system has. So I think what I'm going to do is just stop here, and because the next section I'm going to talk about is the theoretical. I'm going to go into some physics. So for that, I think we'll wait till the next time so that I don't end up with too long a file. And so we'll see you the next time. As a good friend of mine said, always build from the heart, and we'll see you in the bar.